Hey, AP Statistics, continuing into section 4.2. So we've already covered a couple of different elements of experimental design. So we had randomization, and we have comparative design. So all key features, we're gonna get into a few more here. So control means keeping the other variables constant for all of the experimental units. So we try and change our one variable. Our whole goal, I think it was like kind of a big machine. You're just kind of adjusting one knob, tweaking one variable, and then seeing what happens, to seeing what the changes are, what the differences are. Keep everything else the same. If you go changing a whole bunch of things at once, we won't know what actually caused the effect, what actually caused the change. So you adjust one thing, and then you control that one variable, and then you see how things turn out. So. After randomly assigning treatments and controlling other variables, treatment groups should be about the same, so that should come from randomization, except for the treatments. The treatment should be that one thing. And then a difference in the average response could either be because of the treatments, or it could be the random assignment. So there's still a chance, right? Just because you observe a difference between your response doesn't necessarily mean that it was your treatments that caused it. We controlled for some variables, but there was some chance, right? Some people might just respond more favorably or worse than others. So there's also the chance that it was randomness. So ultimately, we want to get to the point where we see a big enough difference that we say it's not chance, right? That it's too big of a difference that it's unlikely due to chance, and we call that concept statistically significant. So we can't necessarily say that any difference in the average response between the treatment groups must be caused by the treatments, because there would likely be some difference in just due to random assignment. And so we don't necessarily know those groups are going to be exactly equivalent. We think randomness should do a pretty good job, but we'll have to understand probability, and that's part of inference. We'll do significance testing is the concept with that, where are these results different enough? Not just slightly different, because slightly different could just be random fluctuations, but a big difference between those that we know that is a significant effect. And so one thing that's going to help us with this, which is going to reduce the randomness, is to do the effects of randomness, is to do replication. And so statistical replication is about using a lot of experimental units, using a lot of individuals, using a lot of subjects in our study, so that the effects of chance variation, it's going to reduce that effect, so that we can better kind of distinguish the effects of the treatments from the chance. So if I just randomly assign a small number of people, it's going to be more kind of wildly variable, where like some people who are going to just do well no matter what treatment they got ended up in one treatment or over another, and so that can throw off the results. But long term, if we do it enough, it averages out, and so we should get kind of better representative groups in those different treatments. Again, in statistics, this concept is a little bit different than replication in science. So we're talking about using enough subjects, repeating it on enough individuals, using a big enough sample size. In other fields, the term replication has a different meaning. So in science, a lot of times they talk about replication. You're saying actually somebody else repeats your whole experiment and can kind of repeat those same results. That's also good, but that's not, when we say replication from a statistical standpoint, we're just looking at our individual study. That's what we mean, is repeat that experiment on enough individuals, get a big enough sample size, or enough volunteers. And sometimes it's not, we'll get to that, but get a big enough group of individuals so that when you do that random assignment, it's not as, chance doesn't have as much say in kind of how things end up. It should kind of average out. So we've gone over a bunch of different concepts. So here we're going to kind of put it all together. So all the basic principles of experimental design. We've talked about each of these in the last couple of videos. So an experiment should have all of these features. It should have comparison. So where you're comparing two or more treatments. It could be a control group, doesn't necessarily have to be in a treatment, or it could just be a couple of treatments or more. It should have random assignment. All experiments should have random assignment. We shouldn't choose where the individuals end up or let them choose. We should use randomness to choose that, so that any other variables that we can't control for, or we forget to control for, or we don't realize we should, or what have you, those should get still kind of split fairly evenly between the treatment groups, and so create roughly equivalent groups. They're still, it's not guaranteed, but that. And then we should keep all other variables the same, the variables we can control, treat those treatments the exact same. That way, the differences we see, we can attribute to our treatment or maybe just randomness. And then finally replicate to overall reduce the effect of randomness. So randomization, replication, control, and comparison. Yeah, so I know that, in the wrong order there, but those are all the key parts that we should be looking for in a well-designed experiment. So kind of putting it all together again, a completely randomized design. We'll get into some other randomized design, but in a completely randomized design experiment, what we do is we get our experimental units and then we assign them to treatments completely by chance. And we'll draw these little pictures, and you can draw these little pictures actually in like your responses, even on like an AP test. You can kind of, if you want to write out a paragraph, you can, but you can also draw a little picture of kind of how you do it. I've seen that on some of these. So you take your experimental units. These are your individuals that have been selected to be part of your study. Maybe ideally a random sample. Sometimes though you have to end up working with volunteers, and we'll address that. So then you take those folks, you randomize, you go through random assignment to split them into a number of groups, right? And so the kind of most basic would be 2 groups. Where you're doing comparative design, you have to have at least 2, but you might have more than 2. Then once you have those groups split up from your random assignment, then you can assign them treatments. And you should pick which group 1's going to get treatment 1, group 2 is going to get treatment 2. You should pick that in advance. You shouldn't wait and see how the groups end up and then say, oh, okay, I picked this group to get the treatment, because that could impose some bias. And then finally, we compare the results, compare the response variable between those. And so then, if we go through that whole process, if those results there's a big enough difference, and we can do some analysis later on to see how big that difference needs to be, then we attribute that to a cause-effect relationship with that one variable we tweaked, that treatment variable, causing that effect. So that is the entire experimental design kind of all brought together.